Good morning, everyone.
Good morning, ma'am.
Yeah, I will just wait for 1 more minute till everybody joins, then we'll continue. Should we start?
Yes, ma'am.
All right. Okay, now we are going to begin with the last unit of your syllabus, which is quite simple. I mean, it is more generic as compared to other topics that were there. We are going to learn, in the previous chapter, we had learned about application layer. So we learned different applications that reside and how the application layer protocols support those applications. Like, for example, we learned about DNS. We learned about hypertext transfer protocol, that is HTTP. We learned about SMTP and email. So all these are applications which work on the internet or which work on a network. So this particular chapter is more general, in which we are going to learn what is meant by network management and why is it important. First of all, we all know what is meant by a network. A network is a combination or an interconnection among 2 or more devices. Now, these devices could be computers, could be machines, could be mobile phones. It could be connection between a phone and a router or other devices like multiplexers. So there are so many types of components that make up a network, especially when you have a large network which consists of desktop machines or maybe laptops, palm tops, and other utilities, maybe software, maybe middleware, or sometimes maybe devices like routers, multiplexers, and so on, modulators, then it is very important that we are able to manage these resources, because a network is made up of so many components and so many resources. We should be able to manage them well so that they work efficiently and are more productive in giving us the kind of results that we expect from them. So network management basically deals with managing the resources, or monitoring, testing, and configuring the components of a network. We'll shortly have a look at the definition. Network management is nothing but monitoring, testing, configuring, and troubleshooting the components of a network. Now, monitoring means what? Monitoring in the sense controlling or supervising, checking whether they are working correctly or not. Then testing, that is, so many components you have to check whether they are working correctly. Configuring them, making the settings according to the necessities. And troubleshooting. Troubleshooting means by chance any one of the components is not working well, or any one of the machines is unable to interact, then the network management system will be able to overcome that trouble, overcome that problem. That is called as troubleshooting. So generally, network components that are there in an organization, they must meet a set of requirements defined by the organization. Okay. Now, these could be more like standards that are set by the organization. For example, maybe one particular organization wants the response time to be very little. Response time to be less in the sense the data should go and the acknowledgement should come back within a specified or very least amount of time. So such policies, such requirements, the system, the organization can impose on the network, and the network components must be able to meet those requirements. They must be able to come up to those standards. So management systems use, network management system uses hardware, software, as well as human beings. All three are the part of a network management system. What all? Hardware, that is the different physical components, software which work on these hardware, and human beings who are going to give inputs or receive outputs from these components. All three of them make up the important parts of the network management system. Okay. Now, we should know what are the functions of a network management system. Now, as I told you, a network management system manages a network. So manages a network in the sense it should be able to perform certain important functions that are expected from the network. Some of the important functions of network management system have been highlighted in this particular diagram. If you all can see, the network management system is concerned with configuration management, fault management, performance management, security management, and accounting management. So when I use the word monitoring, testing, and configuring, as well as troubleshooting, all these will come into picture. So basically, network management system is implemented to execute these functions, that is configuration management, fault management, performance management, security management, as well as accounting management. All these make up a network management system. Okay, so we'll start with the first one. We should know what is meant by configuration management. Now, we all know that a network will be made up of number of entities, number of components that are connected to one another. They may be directly connected, physically connected, or they could be even logically connected. So all these entities have an initial configuration when the network is set up, but that can change with time. I'll give you one example. Let us assume you have bought a new mobile phone, okay? And when you buy that new mobile phone, there are certain settings which are default settings of that particular mobile phone. Maybe the wallpaper, maybe the standard time of your phone, or maybe other things like which is the software or the app that you use for calling someone. Such things are initially set up by the manufacturer, and they are called as default settings. But when you buy that phone, you want to make some changes to adjust to your needs. So what you do, you go to settings and then you change those settings. Same way, whatever are the components that are present in a network, which are connected to the network, they have some initial configuration, which is set by the manufacturer at the time when it is manufactured. But these initial configurations can change with time. And such settings, such configuration, which we change, such parameters, which we change, are a part of what we call as the configuration management system. Now, there are two things related to configuration management. One is reconfiguration, second is documentation. Reconfiguration means adjusting the network components and features according to the needs of the user. Now, what are we going to adjust? We could adjust the hardware settings. We could make some changes in the parameters of the software, or the user accounts that are created to access the software, that can be changed. When we make changes in the existing settings of the components of a network, it is called as a reconfiguration. Re means once again. You are configuring it according to your change. Configuring means changing, adapting it, making some settings, making some adjustment in the parameters to suit your needs. Second part of configuration management is documentation. Now, the original network configuration and each subsequent change must be recorded meticulously. Means what? Initially, whatever was the configuration, that should be noted down. It should be stored somewhere. And every time we make some changes, that has also to be recorded. That means it has to be stored somewhere. You may wonder, why do we require this? What happens sometimes is the network is handled by different people. There are so many components that make up a network. Suppose you are a network supervisor or a network administrator. Now you have made some settings and you leave the job. The moment you leave the job, someone else will take up your job. Now he should be able to know what are the initial settings and how have you changed it, so that he can make necessary changes according to the needs of the organization. Recording means noting down or writing down or storing the details about the configuration, original configuration, as well as every change. Every time you change the configuration, it will be stored, it will be recorded and stored. That is called as configuration management. Okay. Now, the next thing that we must know, which is a function of the network management system, is fault management. Now, we all know that network, is made up of a lot of components. We expect that all these components operate properly. Proper operation of the network will depend on the proper operation of each component. So if all your components of the network are working correctly and they are able to give you the expected output, then there is no problem. But many a times, since there are so many hardware components, many a times you have downloaded some software components, there could be faults that exist in the network, and that needs to be taken care of. So fault management is the area of network management which handles this issue. This issue means issue of problems that can occur in a network, how to overcome them. That is managed, or that is handled with the help of what we call as fault management. I'll give you one example. Imagine we have a computer and we have some hard disk in it, and it is connected to some other server maybe. Okay, and maybe the server hard disk is getting full. Now once it gets full and you try to store something in it, it will give you an error message saying that the disk is full, you are unable to write. Now what is the fault that has occurred there? What is the problem that has occurred? The existing hard disk has become full. So what is the how do you solve it? What is the task of the administrator or the network supervisor? Take a backup of that particular disk and store it somewhere, and make the disk empty, so that anytime a client is trying to send data and store it on the hard disk of the server, it can easily be done. So handling such issues, where we try to understand the faults that are occurring in the network and we try to overcome them, is called as fault management. Now there are two ways, two subsystems of fault management system. One is called as reactive fault management, and the second one is called as proactive fault management. Now, reactive fault management means what? It takes care of the fault after it has happened. Means it doesn't well in advance assume that the fault is going to occur. It's like I said, the disk has become full, and after it shows you the error message that you are unable to write any more data, then you take a backup and then make the disk empty. This is called as reactive fault management. You reacted to the fault, or the system is reacting to the fault. Such a management system which is responsible for detecting, isolating, correcting, and recording faults is called as reactive fault management. But sometimes, not always, but sometimes it may be possible to assume in advance what faults could occur and we can take care of it. Such a management system is called as proactive fault management. Now, what do you mean by proactive? We in advance only we assume, or we think, we anticipate those faults. So such a fault management system tries to prevent the faults from occurring, but it is always not possible to predict in advance. Some types of failures can be predicted and they can also be prevented. Such a mechanism where in advance we try to know what all faults can occur and take care of them, that is called as proactive fault management. I hope I'm clear. So there are two types. One is called as reactive. The second one is called as proactive. Okay. Now, the next function of network management system is performance management. Now, usually when we have a network, we want it to work and give us the best performance. Now, what do you mean by performance? We want a network should be such that it should not have any faults. It should not crash. It should not keep on giving you error messages. A network which is able to handle as much traffic as you send. A network which is able to, transmit the data and get back the acknowledgements very quickly. Such a network would be called as a good network. So how are you measuring, how are you quantifying the performance of a network? That will decide what we call as the performance management. So performance management is closely related to fault management. I'll give you one example. Generally, suppose you want to buy a new bike. What do you try to look? You don't look for color of the bike, or you don't look for how it looks, the look of the bike. What you look for is mileage. What you look for is the engine capacity. How well can the engine work? So what are you looking for? You're looking for performance of that bike. Once you buy the bike, you have invested some money in that bike. The bike should be able to, it should have good speed. It should have good mileage. It should consume less petrol or less fuel. Such a bike we would call it as a good bike. So what we are doing, we are trying to judge its performance. Same way, in a network also, we want to monitor and control the network, and we want to quantify its performance. We want to check its performance with some measurable quantity. Generally, the performance management of a network is measured using capacity, traffic, throughput, and response time. Capacity means what is the transmission capacity of that network? How many packets can it forward at a time? Or what is the bandwidth of that particular network? Traffic means when you have load on the network, whether it is able to handle that many input packets and that many output packets. So that is traffic. So load it should be able to handle well. Throughput means work done per unit of time. So a number of packets that a network is able to transmit per unit of time is throughput. Now, if the throughput is higher, performance is better. Similarly, response time required for a packet to go and for the response to come back, that is acknowledgement to come back, that is called as response time. Okay, so response time should also be less. Throughput should be high and response time should be less. With the help of all these factors, we are able to check the performance of a network. Okay. Okay, so we know what is performance management. Now we should know what is meant by security management. Security of a network is an important issue. See, in a network, multiple machines are connected together. Many machines are interacting with each other. So there is sharing of data, or there could be data which is of highest confidentiality, which is being transmitted. So it is very important that we ensure the security of the network. Security management is related to controlling access to the network based on a predefined policy. Means what? Everybody should not get open access to the network. If everybody gets open access to the network, your data can, be hacked. It can be corrupted. It can be misused. So malicious users can be there. So we have to ensure that the network is not affected. We are able to transmit and receive the data easily. At the same time, we should secure it from external users or external hackers. Such policies which give good security to the system make up the security management. The security management is one aspect which we are going to learn in detail in tomorrow's class. Other aspects we should just know. We should just know what is that definition. But security management we have to learn in detail, which I'll teach you tomorrow. Okay. The next is what we call as accounting management. Now, what is accounting management? There could be many users, all right, and all these users are going to access the network. So we are going to control the access to the network through charges. Means if suppose there's an organization and there are many users, many departments, many projects are there, then the amount of network services that they get, they're going to be charged. Charging doesn't necessarily mean cost. Charging could mean how much amount of time they are able to use the services. What could be the bandwidth that is provided to them? Now, why all this is required? When there is a huge organization, there could be many departments which want lot of bandwidth, they want lot of network resources. So such accounting management, it prevents users from monopolizing the network resources. It prevents users from using the system inefficiently, and network managers can do short and long-term planning based on the demand for the network. I'll give you one example. In our college, we have internet, and we have the internet service is there throughout the day, but there is limited access. And every user who is there, for example, student, they will be able to access the internet maybe for 1 hour every day free of cost. Now, why it is not given full time or all 24/7? Because we have some limited network resources, and there are about 3,000, 4,000 students in our college. If all of them are going to access at the same time, we could be short of the resources. Similarly, there could be certain projects, certain departments, like for example, principal, he might require internet access to the fullest. So there he will be given more importance, he will be given more resources as compared to other faculty members. So depending on the type of user, depending on the priority of the user, the kind of user he is, the user's control can be managed, and that is called as accounting management. That will help an administrator or a network supervisor to manage the resources of a network correctly. Okay, so I hope I'm clear till here. I'll just quickly show you this diagram once again. Everybody is clear with this diagram now?
Yes, yes, ma'am.
Yeah, we have functions of a network management system, and that is related to configuration management and fault management, performance management, security management, and accounting management. All right. Okay, now what we will do is we will try to learn one simple protocol which is used for network management, and that is called a Simple Network Management Protocol, SNMP. Okay, now this diagram is not really very clear, but I will try to explain it. The reason is I have taken this diagram directly from the book, and I'll try to explain it as easily as possible. Okay. So when we have a network and when we have number of components that are connected to the network, it is necessary to manage the network well. Now, generally in a network, a kind of protocol is used which can manage your resources very well, and that is called as Simple Network Management Protocol. Okay, SNMP stands for Simple Network Management Protocol. Now, what is the Simple Network Management Protocol? To understand that, let us try to understand two important components of SNMP, or two important aspects of SNMP. Now, if you all can see this diagram, there are two main components here. One is the manager component or the manager aspect. Okay, the other one is the agent aspect. So generally in a network, when you have many components connected together, one of them in SNMP protocol, one of them is a manager component or a managing station, and the other one is called as an agent. Now, what is this managing manager and what is this agent? We will try to understand it very clearly later. Okay, have a look at this diagram and see. The manager could be connected through the internet to many agents. Right now in this diagram, only one agent is shown, but one manager can manage multiple agents. So what is the use of the manager? Now, manager is like a remote host or a remotely situated machine, and agents could be other resources that are there. For example, an agent could be a router. So you may sit at your place, you may sit at your machine, you become the manager, the machine that you're using. That is called as SNMP client. And there could be, the manager will be executing SNMP client, and there could be agent, which is a router. And sitting on your machine remotely, you can manage the router. Means you can decide the configuration of the router. You can check whether the router is working correctly or not. If you want, you can reboot the router. So you as a user will be remotely sitting on this machine. That is the manager machine. Router will be actually implemented somewhere else. But with the help of internet and with the help of SNMP, you can access that agent, you can access that router and configure it, manage it, and take care of the network. Such a protocol is called as the SNMP protocol. Now we will have a look at these two aspects, that is manager as well as agent once again. Okay, we'll have a look at these two components once again. Okay, now let us try to understand what are managers. Like I said, managers are nothing but hosts or computers on which a user could be operating. A user like you and me could be operating on that particular machine. So a manager is nothing but a host. What does the host do? It manages many routers. In the diagram, only one router or one agent is shown, but one host can manage multiple routers. Now, what does the host do? The host tries to access the values that are present in the database of the agent, that is database of the router. So router or that agent is responsible for storing some values or storing some parameters. Those are accessed by the host remotely, and then they are set, then they are configured in order to check whether they are correct or not. If they are not, then they could be modified. For example, we'll go back to this diagram. If you all can see now in this diagram, there is this machine which is called as the agent. And as I said, agent is nothing but a router. Okay, so suppose there's a router and suppose you are sitting on a remote machine. For example, you are sitting at your home and this agent or this router is situated somewhere in our college. So you can sit at home and manage that router, all right, with the help of SNMP. So we will see one example for this. So what the host or the manager is responsible? It is responsible for accessing the values present at the agent database. Now a router or that agent can store appropriate variables. For example, it can store the number of packets received and the number of packets forwarded. You know a router, isn't it? A router is responsible for taking the data over incoming line and forwarding over outgoing line. So the router can, when the packets are coming at the router can maintain a database where it can store the number of packets received. For example, number of packets received could be 30 and number of packets forwarded could be 20. So that means what, 10 didn't get forwarded or were not forwarded at that particular moment of time. That data can be sent back to the host. Host can access that data and check whether the router is working correctly or not. So manager or the host can fetch those values, compare those values with the variables to see if the router is congested or router is working correctly or not, and take the necessary action. Okay. Now, one more example. Manager can also make the router perform certain tasks. Now, it's like, you are sitting on a remote host and you are managing that router. So, manager can decide what functions the router should perform. For example, a router periodically checks the value of a reboot counter. Inside a router, there could be a reboot counter which is set to some value. So say, for example, that reboot counter is set to 10. Every tick of time, that 10, it goes on decrementing. So 10, 9, 8, so on up to 0. The moment it reaches 0, the manager will make the router to restart itself. Manager can use this feature to reboot the agent remotely anytime. So either the router can periodically boot after it has reached 0, or manager can send a packet with the value 0 in the counter and force that particular router to reboot. Now these are two examples that I have given you. One example is manager can check how many packets were received by the router, how many were forwarded, and it can check whether the router is working correctly or not. Second example that we gave was how the manager can force the router to reboot. Now, these two examples are telling you that the manager, which is remotely situated, the user or the operator who's using that host will be able to manage a remotely situated router. Okay. Similarly, in SNMP protocol, there are certain machines in general which are called as agents. Usually, agents are nothing but routers that run the SNMP server program. Now, what these agents are going to do, they are going to keep data about performance of that router inside a database. So agents can also contribute to management process. Agents, since they store that data, the host will be able to get the data and manage it accordingly. So the server program running on the agent can check the environment, and if it notices something unusual, then it can send a warning message which is called as a trap to the manager. So on its own also, the manager can definitely manage the router by checking for values. On its own also, agent can see whether any unusual parameters are there and send a warning message to the manager so that manager can take the necessary action. This interaction between the manager and agent happens with the help of protocol which is called as SNMP, Secure Network Management Protocol. So there are basically three important things that you should know about SNMP. One is a manager checks an agent by requesting information that reflects the behavior of the agent. That means a manager will send a request and check whether that agent or that router is working correctly or not. Whatever reply it gets back, whatever values it gets back, parameters it gets back, based on that it will decide whether to take the action. Secondly, manager can force an agent to perform a task. So on its own, the agent will be performing task, but the manager also has the ability to force an agent to perform a task by resetting certain values in the database. Third is agent itself, not only manager, but agent itself can do management by, if it finds any unusual parameters, any unusual values in the database, it can send a message back to the manager and tell the manager and give the manager a warning about certain unusual situations. So this is how SNMP is going to work. It is going to work with the help of interaction between the manager and the agent. Okay. All right. Now, I think we are almost done. Whatever I wanted to tell you today, you have a look at this part. I think Rishikesh can answer on behalf of everybody. I think this initial part is clear. What is network management and this diagram? What are the definitions? Definitions of each one of them. In the exam, they'll ask you definition only. What is configuration management or what is fault management and so on. Okay. And then comes this part, SNMP. So SNMP is simple network management protocol in which there are two components, manager and agent. Manager is a remotely situated host and agent is a router. A person sitting remotely can manage an agent or a router with the help of internet. Okay, or with the help of SNMP. So I told you what is manager, what are the tasks that it performs. Then I have told you what is agent and what are the tasks that it performs, and how both of them together can manage a network and implement good performance of that particular network. Okay. Now today I will only take one class. Tomorrow we will continue again. All right.
Yes, ma'am.
Yeah. So if anybody has, now these notes I will share with you on Monday, most probably, or tomorrow, Sunday. Let's see. And first I'll send it to, I'm only making the notes. So Rishikesh, I will, no need to type them. I'm directly pasting from the textbook. So I will be giving you the soft copy of that in a PDF form. You can share it with everyone.
Yeah. Okay, ma'am.
Yeah. Okay. I hope you all are preparing for exam. See, remember, exam is going to be there, surely. Maybe not immediately, but definitely by the end of May, you can expect the exam to be there. So you have to keep in touch with your subjects. You have got enough time to prepare now. Unless you are preparing, if you assume that there's not going to be any exam, you are wrong. 100% there's going to be exam. I have spoken with one of the, one of the authority in the university 2-3 days back, and he said, surely exams will be there, only it won't be conducted now. It will be conducted in the last week of May or the first week of June. Okay. So all of you should be studying well. All right.
Yes, ma'am.
Yeah. We will stop here and we'll continue tomorrow again. I'll let you know the time. Hello.